Welcome to Goodyear's Interactive Education Series. This is the follow-up unit to the introductory program on uniformity. This session focuses on the mixing process. Why are we focusing on mixing? We know that the way you do each step of your job impacts other steps all the way down the line, from extruding to cutting through final finish and shipping. You're here today because Goodyear is committed to giving you every opportunity to learn and improve upon the skills and knowledge you need to do your part in manufacturing the highest quality tires possible. As a tire manufacturer, Goodyear strives to make tires that meet or exceed our customers' expectations every time they get behind the wheel. And what are their expectations? Well, they're the same as yours or mine. Quality tires that provide a smooth, safe ride. Quality isn't something that can be added at the end of the production process. It has to be built in from the beginning. It has to be in our processes, in our procedures, and most important, in our associates. Building quality tires begins with hiring talented, quality people like you. Goodyear has designed this interactive program with the following outcomes in mind. We want you to understand what our customers expect, recognize how each phase of the manufacturing process is linked together, understand why uniformity is critical to the production of tires, understand why it's important to do each job according to the defined specification. The purpose of this session is to make the connection between your job in mixing and tire uniformity and show you why doing your job the right way every time is essential to uniformity and ultimately customer satisfaction. This is a self-paced program. Take as much time as you need to understand the material. Icons on each. It's been a while since the introduction class. Do you remember what driving disturbance is caused by conicity? How about radial force variation? To begin, let's refresh your memory with a short video segment reviewing uniformity parameters and other information covered in the first session. You may also click on the blue underlined text for a pop-up definition of the uniformity defect. After the video runs, you'll be asked a series of review questions. While it's important that you are familiar with the uniformity defects and understand that they cause driving disturbances, it's more important that you clearly understand that what you do in mixing directly affects the other links in the chain, tire uniformity and customer satisfaction. In our day-to-day lives, we expect a little non-conformity. But in manufacturing, uniformity is essential to maintaining high quality and ensuring customer satisfaction. And as we showed you in the first session of this series, that's certainly true of Goodyear tires. In that first session, we also talked about the fact that the tire manufacturing process is like a chain. And whether you work in materials receiving and handling, way down the line in final finish and testing, or anywhere in between, what you do in your step in the process affects the other links in the chain. Even minor variations in the process can lead to uniformity defects that can generate forces in ways that can be seen and felt by a driver. A tire with a radial force variation hits the road with varying pressure as it rotates, causing a bumpy ride. A tire with excessive lateral force variation has defects that cause it to wobble as it turns. A tire with high conicity rolls like a cone and causes the vehicle to feel like it's drifting to one side. And when a tire has a balance defect, the driver may feel a side-to-side vibration in the steering wheel. The vehicle may bounce up and down, or have the sensation that a tire is flat. Obviously, bouncing, vibrating, pulling tires are not acceptable to us or to our customers. That's why this series is called Uniformity, from the customer to you. Because our customers set the standard for Goodyear quality by telling you, the men and women who make Goodyear tires, what they expect from our products. To gauge our success, Goodyear has developed a series of tests that allow us to measure forces in our tires that affect vehicle ride. A tire that passes these tests meets all of our standards for uniformity. Remember, uniformity standards are like a strike zone. The tire doesn't have to be right down the middle of the plate to be a strike. It can catch a corner of the plate and still be within acceptable force limits. But these tests are not the key to uniformity. They're merely a safety net. Doing things the right way every time is the key. Now in today's session, we're going to turn things around. We're not going to tell you how to do your job. Instead, we're going to take a closer look at your job, your link in the chain, and show you how you impact uniformity and why doing your job the right way makes a difference to our customers. Let's begin by answering some review questions. Remember, more than one answer may apply. If a tire has high radial force, what ride disturbance does the driver feel? Vehicle vibrates from side to side. Vehicle bounces up and down. Vehicle pulls to one side. Tire feels flat. That's right. If a tire has high radial force, the driver will feel like the vehicle is bouncing up and down. If a tire has high lateral force, what does the driver feel? Choose all answers that apply. That answer is incorrect. Let's review. When you hear the answer you're looking for, click Back to Question to go back to the quiz. In our day-to-day lives, we expect a little non-conformity. But in manufacturing, uniformity is essential to maintaining high quality and ensuring customer satisfaction. And as we showed you in the first session of this series, that's certainly true of Goodyear tires. In that first session, we also talked about the fact that the tire manufacturing process is like a chain. And whether you work in materials, receiving and handling, way down the line in final finish and testing, or anywhere in That's right. If a tire has high lateral force, the vehicle vibrates from side to side. If a tire has high conicity, what disturbance will the driver feel? Choose all answers that apply. That's right. If a tire has high conicity, the vehicle pulls to one side. If a tire has high balance, what disturbance does the driver feel? Again, more than one answer may apply. That answer is incorrect. Let's review. When you hear the answer you're looking for, click Back to Question to go back to the quiz. In our day-to-day life, yes, if a tire has high balance, the driver feels the vehicle vibrate from side to side, or the vehicle bounces up and down, or the tire feels flat. True or false? Uniformity parameters are the key to uniformity. Yes, that's false. Doing your job the right way is the key. That means doing every task or must-do associated with your job to spec every time. What are the problems that can occur when you're not doing your job the right way or working in spec during tire production? Yes, all of these driving disturbances could be the result of not staying in spec. Working out of spec results in a lack of uniformity. Who sets the standard for tire uniformity? That's right. Our customers set the standard for Goodyear quality. How do they do that? By choosing Goodyear tires over the many brands that are available. Who is responsible for tire uniformity? That's right. You are. You are responsible for making sure our customers get the quality they've come to expect from Goodyear tires. After all, what is uniformity? To our customers, uniformity is a smooth, safe ride. For you and everyone involved in the tire manufacturing process, uniformity is consistency. That means consistently following the specifications developed by Goodyear for each of the steps or must-dos involved in mixing. You can probably imagine how variations in the process of extruding or tire assembly can affect uniformity. But mixing? How can you affect uniformity? It may not be clear right now, but by the time you get done with this session, you'll see how working to specifications leads to quality and how not following specifications results in a driving disturbance. Because the fact is, if you're not contributing to uniformity and a smooth, safe ride, you're contributing to the bumpy, vibrating ride that's caused when tires have uniformity defects. Think of the tire manufacturing process as the same process you'd use to make a batch of biscuits. Being in mixing is like mixing the dough.